Welcome, everyone. We're going to get started in just a couple more minutes. All right, let's get started. Welcome, everyone. I'm really excited that all of you are here joining into this workshop today. We are focusing on building end-to-end IoT solutions, and today we are going to deep dive into working with Azure IoT Edge. My name is Pamela Cortez. I am on the Azure IoT team. I focus on developer communities, creating technical content, and a lot of training, and specialize in embedded developer communities as well. So I'm excited for us to deep dive into Edge today. This is a part of a workshop series. If this is the first one you've attended, we do have other ones if you're interested. The other ones include Transform Your Business with IoT. This one's all about what are all of our products and services and how do they map in with each other. This one's a really great starting one, especially if you aren't familiar with our products and services, because there is a lot of products and services to build IoT solutions with, and our Microsoft portfolio is pretty huge. So it can be a little overwhelming when you first look until you break it down and understand what value certain products bring versus others. And then the next one that we did was the devices and device communication. This one was all about IoT Hub. IoT Hub is one of our top products, which it does bi-directional communication. It's really that cloud gateway from the device to Azure. And so we deep dived into IoT Hub on that one. The next one that we did was the device provisioning at scale. That one was really deep diving into device provisioning service, all about how to register, do configuration, how do you provision tons of devices, all at scale. And then we did the messaging processing, analytics, and business integration. That one was definitely a jam-packed one. We were covering event grid integration with IoT Hub, time series insights, also Azure Stream Analytics, which I will showcase Azure Stream Analytics when it comes to IoT Edge today. But if you haven't heard of Azure Stream Analytics, I recommend checking out that one to get a little bit more information. And let's go ahead and get started for this work with Azure IoT Edge. If you're joining us live, so all of you right now, if you have questions, we have some amazing folks who are online right now, ready to answer those questions. So they're helping me out, which I really appreciate. So huge shout out for those guys. That way I can show more material and get to your questions offline. All right, so then the agenda today, we are going to go over IoT Edge overview. We're going to go into, the IoT Edge runtime. What are all the different features and different products that also support IoT Edge? Then we're going to do an AI on the Edge overview. And it's really going to be a kind of a high-level overview for AI on the Edge because we have a lot of great videos already covering AI on the Edge, which I will link to that, and I will also talk about the different workshops that you can focus on and do after the event if you are really passionate about AI on the Edge. Then I'll go into the tooling support for IoT Edge. This is meaning, can you use Visual Studio Code? What is the support for Visual Studio? So we'll deep dive into those different tooling support. And then the lab today, we're going to set up and deploy an IoT Edge device. I'm going to show a couple different ways to do that, and also through the portal, showcase a couple different options that you have, and then we are going to go ahead and configure the IoT Edge device as well. And then we'll end with tons of developer resources because we have so many workshops about IoT Edge, and I'm really excited to list those resources for you. So after the event, there is an unlimited amount of material for everyone to go through. And then getting started with the lab that you saw myself cover today, and also other potential learning paths that you can take. To get started with, let's kind of look at how where Edge came in when it came to the innovations that happened for IoT. So we started off with the cloud. So we had all of these, great global, available, unlimited compute resources in the cloud. IoT came where we harnessed the signals from those sensors and devices to have that managed centrally by the cloud, and so that definitely helped a lot moving forward on IoT. But really, what unlocked and was really innovative was Edge support. So bringing all of that intelligence, that all of the workloads that we were able to do on the cloud, actually bringing that back to the devices, which is kind of an interesting thing to think about, because before the cloud, it was machine to machine, and then we had the cloud, and then we were taking all of that data back up, or all the data from the devices to the cloud, and then now we're bringing that intelligence, stream processing, all of those different workloads on the edge. So it's kind of an interesting progression that we've seen with in this particular industry. And then the next thing is AI, and that's not only the AI on the cloud side, but also actually bringing AI to the edge. And this is, we'll cover this in a little bit, but this is really powerful, and you'll understand why and how that unlocks a whole different set of scenarios that wasn't there before. And then digital twins. We won't cover digital twins for this session, but if you're super interested in digital twins, at Build, we will be talking about digital twins. Build is one of our big annual developer events. So if you're interested in developer or digital twins, join us next week and definitely check out those sessions. So I talked about IoT in the cloud, and then IoT on the edge as part of that progression of innovation. But let's kind of dig into, the differences between and the challenges between having it on the cloud and having IoT on the edge. So when we think of IoT in the cloud, we have remote monitoring, we could do all of the management, we can do all of the machine learning in the cloud side. We could do some merging of remote data from multiple IoT devices. We have unlimited compute, unlimited storage to really train these machine learning, and also all of these advanced AI tools on the cloud side. And then for the edge, lots of times, the reason why people want to go to the edge is because they have offline scenarios. So this is where edge becomes really beneficial, and moving those workloads to the edge is to support those offline operations. And this could be short term or long term. And so we'll get into that in a moment and a couple examples. But this, I would say, most of the scenarios I see and worked with when coding with partners and customers have been offline operations. And then there's also kind of that privacy of data, especially when we're bringing AI to the edge. You can imagine there's all of these, machine learning modules that are being developed, and you want to be able to protect that IP. And then you also want to protect the data that's going into those modules. And I'll give a couple of examples in the next slide. Also, pre-processing of data is really important. When you think about streaming so much data to the cloud, that can start becoming really expensive. And then also you have to think about latency as well. I always give the example of security cameras. If you need to send an alert as fast as possible, maybe you want to be able to do that on the edge side. That way you can have instant notification to someone who might be able to help, if a security camera picked up something. And so when latency or timing is really important, you want to be able to process all of that data and then go back to the security camera. Video feeds, sending it all to the cloud can be really, really expensive. And then also there's devices that can't actually connect to the cloud. And we'll talk about, how to set up your edge as gateway. And so, edge, you're able to do that protocol translation, data normalization, which is really important. So you have all of these really small devices, maybe that have no way to connect to the cloud, but you could connect to a gateway device, which then you can send that data up to the cloud. A couple more challenges that we think about and some barriers. One, the cloud barriers. There's a high volume of data collection sources, which you can imagine all the different types of devices and the types of data that they're sending. That can be a barrier. It's really expensive, as I just mentioned. Sitting all of this video feed or sending tons and tons of data that maybe doesn't really need to be sent to the cloud. Maybe you only need to process a little bit of the data on the edge side and only send up the important things like alerts to cloud. So, some people, especially in certain scenarios, it doesn't make sense for them to send all of the data up. Limits to real-time insights. This comes back to timing and that latency. You really want real-time instead of that near-time insights. And then edge barriers. Lots of times when it comes with scenarios that involve bringing in edge, especially when you're involving bringing, AI or intelligence to the edge or machine learning models and deploying them on gateway. One of the things you have to think about is that it's a high developer skill set for hardware, cloud, and edge. So I've worked with a lot of different teams where, different companies, they'll have, folks who work on the hardware side, the embedded developers, and then you have your data scientists, machine learning experts, and lots of times they don't talk to each other. And so when companies are starting to introduce, edge IoT solutions, they have to bring those teams together. And so sometimes that can be kind of hard for companies to have, because the embedded developers might have different tooling compared to, the data scientist. So there's some interesting challenges that I've seen when working with different companies to think about. And not always, it's not very easy to find developers who know all three of that: hardware, cloud, edge, and then the fourth, AI. Custom code for everything, that is a huge barrier for edge solutions, and manual setup and integration. That does not scale. So if you have a device and you're doing everything manually, that, especially if you have thousands and thousands of devices, that is going to take forever. It's going to be really hard to go into production if you have to do everything manually set up. It's one thing to do one device. It's another thing to do many, many devices. So this is kind of that traditional IoT IoT pattern. So you have the devices create data locally, they send it to the cloud where it's processed with high value AI or machine learning to produce the business insights. So you can see what I just said. Oh. And then those actions, depending on the insights, then go back to the device. So this is a very, very high level pattern that we see in IoT scenarios, and this is great. However, the biggest thing that we have seen and got feedback from partners and customers is that this doesn't always work. This pattern doesn't work a lot of time for different scenarios for a couple different reasons. One, flaky internet connections. So you can imagine, you know, if you have flaky internet connection and you have a smart fire alarm system, if the internet goes down, you really don't want this, this type of pattern. You want to be able to make sure that even if the fire alarms need to go off and you don't have internet connection, the fire alarms can still go off. And so that is definitely a limitation when you're sending all the data to the cloud before you bring out an action back to the device. Other thing is the devices are creating a lot of data, as I mentioned before, security cameras, and so sending all of that is it's costly and a lot of latency, and that real-time response is that other you know, feedback we got from partners and customers that, you know, sometimes you really need that real-time responses, especially if a machine goes down. You need to know right away, or in order to set off a manual action, or maybe set off automatic action to fix the machine or be able to do something. So sometimes that near real-time solution doesn't always work. And that's where the Edge, you know, provides those extra benefits. You know, when we talked about the privacy, data privacy, you know, you can, for example, if you are doing autonomous vehicles, with autonomous vehicles, there's a lot of video data that's being sent or being captured. And when you think about privacy, if you have a car that's, you know, you're taking video for training, it's going to pick up a lot of people's faces. And if you need to send that to the cloud, you're going to probably run into some privacy issues there in certain countries. So one thing with the Edge is that you can actually do that processing there on that particular device and only send up information that is relevant, but also make sure you can blur out people's faces or take out personal information before you send it out to the cloud side to gather insights and then actions. So you can see now we brought those insights and actions on the things on your different devices, and it makes things so much easier for a lot of different scenarios that require those different particular offline capabilities, latency, and also cost efficiency. So when we think about IoT Edge, because I just gave you a pattern, but when you think about enabling intelligence on the edge, we do have this thing called Azure IoT Edge. It is a runtime, and so I'm going to give an example of a run through of how it works. So for this example, let's start off with a IoT workload designed for a smart camera. So you can see we have a smart camera right here that you may want to run to the cloud. So first, we're going to go ahead and create some custom code. Maybe this custom code can be used to massage the camera data into a format, maybe to be usable by high volume AI. In this case, for this particular example, it could be image recognition model that is created by Cognitive Services, because Azure Cognitive Services, we do have support for running models on the edge. And then this particular AI produces an insight which triggers an action. So this custom code for the data transformation sits as an own little core container. Cog services sits its own little container, and your custom code for that particular action, be alert or whatever it would be for this particular scenario, would sit in a particular container as well. And so what would happen once you have those different workloads in a container is that you would send those individual containers up to a container registry and put that in the cloud. And I always get the question of, why have all of this in the cloud side? Why put it in a container registry? Mostly because if you have your container, this little bit of code for this data transformation, maybe your cog services for insights or other piece of custom code in a container, it's easier to manage, especially if you have tons of edge devices. So let's say you have one video camera that you need to do image recognition on, and so you could reuse this container for that particular other camera. And so what ends up happening once you have all these containers in the container registry, you then go ahead and send the correct workload description. And so that description in the cloud and target it to correct types of IoT devices. And we'll dig into this a little bit deeper on how that actually works, and I'll actually show you in the lab as well. And so what this workload description is saying is, hey, we have all these particular containers that we want to deploy on this particular camera or device, edge device. The next is to actually deploy that workload and have the IoT Edge runtime. And then what that will do is deploy all of those containers to run that. And then you will be able to run all of those, let's say the AI, the actions, all of the containers will be able to run locally on the device, even in an event of an internet failure. And it's also smart enough to cache data that was bound for the cloud when the internet connection is down and sync once it's reconnected. So this is really nice to be able to have all of this on the edge, even if the internet goes down. And you can see that the Edge runtime is helping in this whole process here, and we'll dig into what this IoT Edge runtime is actually doing. Okay, so IoT Edge features. So I'm going to go through a couple different features of IoT Edge before we actually go into the architecture of IoT Edge and the actual runtime itself, what modules are, is it a container or what is it? So let's just go through the different IoT Edge features. One, IoT Edge is open. So this means that the actual runtime is open source. It's actually based off of Moby. If that sounds familiar for some of you folks, it's because Moby engine is actually Docker uses that. So IoT Edge is based on Moby-based container runtime. So that means it's compatible with Docker containers, which is really nice, especially if you worked with Docker before. One thing I've noticed when folks are just starting off building modules, maybe they've never had Docker training, or this is kind of a new concept for them. So I do always recommend folks to, when they're starting building IoT Edge, do some research about working with containers and just overall how Docker works. And then next, since it's open, we do have an IoT Edge marketplace for Edge modules. This is really great if, let's say, you need to find a module. We have a bunch that's published by Microsoft. We have one for OPC UA. So if you want to do protocol translation there, you have that ability. And it's easy to get all of these different modules from this marketplace. And you can also, if you're a partner or customer, you can submit with, say, a particular module into the marketplace as well. IoT Edge is super secure. We have zero-touch provisioning of edge devices with device provisioning service. This is really big. This helps you be able to deploy and configure a bunch of edge devices at scale. So if you're not familiar with device provisioning service, recommend checking out that other workshop. And then we have security framework that provides end-to-end security and support for different hardware-based root of trust. And then we have trusted computing via Open Enclave for conventional computing. And one thing I also want to mention with security, when it comes to security, we do have Azure Security Center for IoT support. And so if you have edge devices, we do have support there as well. And intelligence. So a lot of support, module support from Microsoft, but also from our partners and customers. So, if you want to do machine learning, we do have support for Azure Machine Learning, Azure Stream Analytics. So, how you can work with Azure Stream Analytics on the cloud side, you can actually work with it on the edge side as well. And then we have COG services, so cognitive services support for edge, and so things like custom vision, facial recognition, we have support there. And then blob storage. This is really important, especially if you're doing AI on the edge. Let's say you have a lot of data and want to be able to store it on the edge. We do have blob storage support. And then we do have support with different partners like NVIDIA. We have support for NVIDIA DeepStream and many more. That's all that can be found on the marketplace. And then there's some people who have created modules and containers that isn't on the marketplace as well and open source them, which is really great. It's enterprise ready. This means that you can scale these deployment with the automatic device configuring service. This is definitely really nice and easy to implement when it comes to IoT Edge. You can get started quickly, especially if you know these different languages, which we try to support many different languages like C. We also support .NET, Node, Python, Java, and so it's not like you have to learn a special, different, unique language for working with IoT Edge. And we have example code and tutorials for each one of those languages too. So if you're like me, a C developer, there's plenty of tutorials to get you started there. And then development tooling and Visual Studio Code. I'll get into that a little bit later. And then deployment tools like CI/CD using VSTS, and so this is actually Azure DevOps. So if you recognize the VSTS, and it is no longer called that, it's actually Azure DevOps. And then we also have IoT Central integration. So where does IoT Edge fit into our Microsoft portfolio? So we do have both PaaS and then build with IoT Central. And so if you are working with IoT Central, we do have Edge support. Just keep in mind that is in preview. So anytime that a feature is in preview, we don't recommend putting it into production yet. Azure IoT Central isn't in preview. It's actually GA, but the feature of IoT Edge is still in preview. And then I did highlight that, with Edge, we have that support with Windows. So if you're working with IoT Edge, you can work with Windows IoT. So if you're already, working with Windows IoT Enterprise or any of the Windows IoT suite, you can work with IoT Edge. We have, a certification program for device for different devices. I'll get into that a little bit later. Azure Stream Analytics support, Azure Storage. So you can see we have a lot of different support for Edge devices. So just to kind of summarize what we just covered before we dig into the actual, what is the runtime, what are the system modules, all of that. Really high level, you can move the cloud custom workloads to the edge. You can have seamless deployment of AI and advanced analytics. You can configure, update, and monitor to the cloud. It's compatible with all different popular operating systems. So you're not just tied to Windows. You have Linux support as well. Even works with ARM. So just keep that in mind if you are, interested in different types of operating systems and if there's support there. And then we have easy development because we have a lot of extension tools with different IDEs that you can use, and then security from chipset to cloud. So we went through this already, just kind of describing that, hey, we have these different containers, and I just want to kind of go back to what that actual module is. So think of modules as a Docker container that you can deploy to IoT Edge devices. It performs a specific task, such as ingesting message from a device, or transforming a message, or sending a message to IoT Hub. It communicates with other modules and sends data to the IoT Edge runtime. And so this is what we highlighted earlier. I just wanted to give that overview one more time before we dig into each one of these elements. All right, so let's talk about the actual runtime. Remember that runtime is based on Moby. It's open source, so you can go on GitHub right now and get access to IoT Edge runtime and installs. So the runtime installs and updates workloads to the device. It maintains the IoT Edge security standards on the device and ensures the IoT Edge modules are always running. It also reports the module health to the cloud for remote monitoring, and then it facilitates communication from downstream Leaf devices and the IoT Edge device itself. It also facilitates communication between modules on the IoT Edge device, and then between IoT Edge device and the cloud. So part of the runtime is that you actually have two system modules, so this runtime focuses kind of on communication and module management. So two of these roles are performed out of these system modules. So you can think of the IoT Edge Hub is responsible for communication, while the IoT Edge agent deploys and monitors the actual modules itself. And before that even starts, you have a thing called the IoT Edge security daemon that starts the IoT Edge agent on startup, on the device startup. That agent then receives its module twin from IoT Hub. It expects the deployment manifest, and the deployment manifest, think of that as it's just a JSON file that declares the modules that need to be started. So I'll go back real quick because I just talked about the deployment manifest is right here, but I just wanted to highlight where that is. So it starts off in the cloud and then it deploys on the device itself. Okay, so going back to the IoT Edge agent, the agent manages this deployment and does the monitoring of the modules on the IoT Edge device, and that actually includes the IoT Edge Hub. It's responsible for instigating the modules, ensuring that they continue to run, and it actually reports the status of the module back to the hub, and then just like any other module, the IoT Edge agent uses the module twin to store its configuration data. And then the Edge Hub actually handles the communication between the modules on the IoT Edge device and between the device to IoT Hub. Using the IoT Edge Hub as a message broker, it keeps those modules independent from each other. These modules only need to specify the outputs in which they accept the message, and then the outputs of which they write the message to. And so I mentioned earlier that, you know, IoT Edge has that extended offline capability. And how that works is that when an IoT Edge device goes offline, this IoT Edge Hub actually does three things. One, it stores any messages that would go upstream and then saves them until the device reconnects. The next thing it does, it acts on the behalf of IoT Hub to authenticate those modules and the child devices so they can continue to operate. And the third thing, it enables communication between child devices that normally go through the hub. So that means that you can also, when you think about offline capability, you could just have a workload where you connect the device, the IoT Edge device, and sync it up to IoT Hub, and then go offline. And you can actually stay offline forever if you really wanted to. You really only need to ping up once to sync with IoT Hub, and then you can then reconnect and resync to IoT Hub once your device comes back online. One thing to keep in mind, though, even though I said, you know, you only need to ping up to IoT Hub once, there are particular services like cognitive services where if you use their Edge modules, they will require you to actually phone home, meaning, be connected to the cloud to be synced up with IoT Hub. And the reason for that is mostly billing. And so keep that in mind, depending on the modules that you have deployed on your device, you might actually have to phone home more times to IoT Hub. But if you want that extended offline capabilities, you do have that option. So kept talking about modules and, you know, going back to modules is really that Docker container that you can deploy on IoT Edge devices. You know, it's really that package containing the software that defines a module. You'll see a lot when people talk about IoT Edge, they'll say container or module. Just keep in mind kind of what that means, and that really the module is a Docker container. You can think of it that way. And there's people who ask, why have a bunch of different modules? Why not just have one big module that does all of your workload on an IoT Edge device? I really recommend having, and it depends on your scenario as well. The reason why people have different modules that contain different, different kind of software or that does a specific task is because if you can imagine, if you have a container that is, or a module that has facial recognition, let's say you want to deploy that facial recognition module to one particular IoT Edge device. Let's say it's this based on a security camera. You can deploy it on that, but you can also reuse that module and deploy it on a different type of device that wants to use that particular technology. Maybe it's a piece of machinery that's on a production floor that needs to do like a conveyor belt that needs to do facial recognition as well, and only needs that piece of code. And so it's nice to have kind of these different types of containers that you can reuse for different purposes. And so that really saves time, especially if you're doing multiple IoT solutions or you need to think about version control. There's a lot of great reasons why it's nice to kind of have these different modules that do these different tasks. A model instance is a specific unit of computing running on the module image on an IoT device. And so this instance is actually started by the IoT Edge runtime. The module identity is just a piece of information, including security credentials that's stored in the hub. It's associated with each module instance. And then a module twin is a JSON document stored in the IoT hub. It contains a state of information for a module instance, including metadata, configurations, and conditions. And anytime with device twin, module twin, they're always created automatically when you have an edge device or would say a non-edge device as well. All right, so we talked about these different modules. So you can imagine, hey, we have a module for telemetry, we have a module for insights, we have a module for maybe this does some sort of action, some sort of particular task. They need to be able to talk to each other. And so we do have this thing called routing, where you want to declare routes. And you do that a couple different ways. And there's you look at it as from, so that is the source, and then where, which is the condition, and then into, which is sync. So you can see for this particular one, you have telemetry, so it's from this telemetry module, and then where this piece of information is going, and then where it's the condition, and then like expression. You think of a condition as an expression on messages of like a property or body. So it could be like a sensor type, which is like temperature, or alert equals true. And then syncs is actually the location for the messages. Think of it as the endpoint. So you can have a sync to upstream that can, send up to IoT hub. And we'll dig into that when we go to the lab as well. And I mentioned end-to-end security for IoT Edge. So with these edge devices, lots of times we kind of think that they need a higher level of security, and that's mostly because they're remotely deployed. This means attackers may have physical access to these devices, unlimited time with them, especially if they're a device that's kind of sitting offline for a long time. You want to make sure that if it's offline, that the device is still really secure. And so this could expose devices to a larger set of, attack vectors. So this is how we think of IoT Edge security as a whole. IoT Edge provides this full security framework to let you guard against many different types of attacks. So for example, the first one is that your device can do a secure boot. This enables you to be able to make sure no one has tampered with the code on the device, and that it's running the same thing that it was, what was flashed when it was in the factory, which is really important. And then, next is the secret storage. And so if the device has a hardware security module like let's say a trusted platform module or TPM, IoT Edge will work with that and have secrets with the hardware. This will guarantee no one will access those secrets, even if they have physical access to the device, which I've definitely seen that before. So, having that ability where even if they have the device, they won't be able to get access or even understand what's going on with the code. The runtime will use hardware protected secrets to encrypt the configuration data as well. The IoT Edge runtime will ensure that correct runtime is running on the device. It will provide a workload identities that can be used to encrypt those communication locally on the device, even in the cloud. And then trusted execution environments. They also, ensure that code cannot be changed after boot. And this is important because if you think of attacks like code interjections, you want to be able to make sure that this runtime can be ran in this environment, and sensitive workload can be run in a trusted execution environment as well, to prevent for the code being changed after boot. And then we offer a security monitoring service that could be ran on the IoT Edge devices to enforce security policies and detect anomalies. I mentioned that Azure Security Center for IoT has support for Edge devices as well. And so that's how we view security as a whole. So when we think of IoT Edge, we could also think of a couple different ways of deploying it as a gateway device. And so here's some gateway patterns to think about, and a couple different scenarios. And the different gateway patterns, there's a couple benefits to this. One being is that if you have analytics on the edge, you want to be able to locally process that data coming from the downstream devices without sending all of the telemetry to the cloud. And we mentioned, I mentioned that earlier. You only want to send that subset of data to IoT Hub. And then another benefit is the downstream device isolation. Maybe a gateway device can shield all of the downstream devices from exposure from the internet. Maybe you don't want any of those devices to have any exposure to the internet. There is one benefit of having a gateway pattern. Your gateway can sit between the OT network and does not have any connectivity, and an IT network where it actually provides access to the web. And then there's traffic smoothing. That's another benefit where the IoT Edge device can automatically implement, exponential backoff if the IoT Hub throttles in the traffic while persisting the messages locally. This is a benefit, especially if your solution, maybe there's spikes in the traffic. It makes your solution more resilient. And then offline support. I think I've mentioned that a lot already on the benefits there. So let's talk about these different gateway patterns that you can actually use IoT Edge with. So transparent. So you can imagine you have all of these different devices. They have their own IoT Hub device identity. They speak a protocol the IoT Hub understands. Maybe they know MQTT, HTTP, and they already have support for that. So that then can go through the IoT Edge runtime, and that just passes the communication between those devices and IoT Hub to IoT Hub. So when you actually go into IoT Hub, those devices all have their own identities. They will still, act like device 1 was connected directly to IoT Hub, or device 2 was connected directly to, IoT Hub. But instead, you have a transparent, or the IoT Edge runtime is acting like a transparent gateway. And so, that is one of the gateway options patterns you can choose. Another one is a protocol translation. I mentioned earlier, not all IoT devices can actually connect to IoT Hub. Like, for example, if you have a wearable device and it's Bluetooth, or other example, all of these devices may be connected through OPC UA. Maybe you want that to connect to a gateway device to do protocol translation before you actually send up the data up to IoT Hub. And so this is really, really useful, especially if you have all these devices that just can't connect anyway, but they can connect to a gateway device. One thing to note by this, though, this protocol translation gateway pattern is that the gateway is the only device that shows up in IoT Hub. So when you go into devices, it will just show up as an edge device, one edge device. And then you have identity translation. This is that, hey, you have actually, let's say, a Bluetooth device or OPC UA device or any type of, device that you need to do protocol and identity translation. You can actually have that go through a gateway device through IoT Edge Runtime that has IoT Edge Runtime deployed on it, and then connect that to IoT Hub, and it will show up as individual devices. So these are the different types of ways that you can have IoT Edge act as a gateway and the different patterns. All right. So one of my favorite things is hardware, and lots of times I get the question of, what type of devices can IoT Edge run on? So if you're thinking of these little small boards with it, or just sensors, it's not going to be able to deploy on a sensor or let's say a really small constrained device. For example, maybe Azure RTOS or Azure Sphere. Our IoT Edge Runtime will not be able to actually deploy on those devices. And the biggest reason for that is because you're using it's based off of Mobi, and if your device can't support Docker or Mobi or anything like that, we wouldn't be able to use IoT Edge. And that comes down to space and other requirements as well. But IoT Edge supports both ARM and Intel architectures. It runs on Linux and Windows, so pretty much any open source or operating system that supports containers. If you're using Windows IoT Enterprise, it supports that as well. So you can see that you can use something as small as, let's say, a Raspberry Pi, all the way to a big server itself. IoT Edge can actually run on those, but it just is not able to run on the really, really constrained devices. We have two ecosystem programs. One is the modules themselves, and then we actually, if you're trying to figure out IoT device that the IoT Edge Runtime could run on, you can check out this device catalog. The device catalog, it's not all of the devices that can use IoT Edge Runtime, but it is a great start. So it's a lot of our different partners that we've worked with over the years that's part of this catalog. If you have a device, or if you're a company that makes devices and you want to showcase your device here, you can also do that as well. But the certification really helps folks know that, hey, IoT Edge Runtime works really great with this particular device. And then also with all of these modules, you can submit modules as well if you want it to be part of the marketplace. As I mentioned before, that Edge, we do have support for IoT Edge and IoT Central, both with device provisioning service, so you could do group enrollments, individual enrollments, and then IoT Edge device management. This is, we have a lot of great examples of using IoT Central with NVIDIA hardware, and so really recommend checking those out. I have a couple of those linked at the end, and I could deep dive into that. If you're not familiar with IoT Central, it really is our IoT app platform for folks to design, deploy, and manage solutions that you can then go ahead and brand and sell to your particular customers. Keep in mind, Edge is only in preview for IoT Central, so I would not use it in production at this moment. We also have support for deploying IoT Edge workloads on Kubernetes. So if you're wanting and interested in having that extra layer of resilient, high availability infrastructure layer, consider looking into this. It's in public preview, but we would love to get your feedback on it. But it pretty much adds hardware failure resiliency to IoT Edge deployments by leveraging Kubernetes platform features, and then manage applications from IoT Edge or IoT Hub with the familiar app model. And then automatic translation to Kubernetes native application models. So if you already know Kubernetes pods, services, deployments, it's really nice. So it's not like you have to learn a bunch of different terminology to be able to deploy IoT Edge workloads on Kubernetes. And then clusters can be shared by multiple Edge devices. We also released this as well, the troubleshooting tool, which is really nice because you're able to do configuration checks, check production readiness. So is your certificates expired? How's everything looking? And then connectivity checks as well. All right, I'm going to go high level on the AI on Edge overview. And so there's a lot of great resources here, but I just want to talk about a couple scenarios. When we think of actually bringing AI on the edge, there's a lot of different particular scenarios across many different industries, but they all kind of bundle up to these kind of high ones. One is time series, and then sound, and then vision. So a lot of people do predictive maintenance, asset configuration, speech, predictive maintenance, again for sound, and then for vision as a sensor, you can think of a camera as a sensor. A couple scenarios for that is workplace safety, smart retail, and smart city. So I've mentioned one scenario being the time series AI. We do have support from a couple different products to support that. So one is Azure Stream Analytics. So we do have autonomy detection now that you can use on the edge. So that support you have on the cloud, now you have on the edge side. So you can actually detect 5 different types of anomalies, spikes, dips, slow, positive, negative trends, bi-level change. You can have unsupervised models for inline learning and real-time scoring. You can easily invoke simple function calls within a query language. And then you also have support from SQL DB Edge. This is in preview, so I definitely recommend checking it out and giving us feedback there. But you can actually have your choice of platform. Time series is already built in. The AI is already built in. You can use Python, R, Spark, Java. It's turnkey management. And then the performance is really amazing, and we have securities is a big part of actually all of our products, but we definitely call it out here for database edge. All right, so mention vision, thinking of cameras as a sensor. So a couple of different types of scenarios you can see there is, in retail, it helps with, shopper experience or buyer experience. So shopper analytics, loss prevention, shelf availability, and industrial space. It can really help with workplace safety, quality control, infrastructure inspection, also in smart spaces, traffic, access control, and public safety. These are just one out of the many things that we see when it comes to computer vision on the edge. And really going back to how innovation has gone a long ways in IoT. Having AI on the edge has really unlocked most of these scenarios, because before it was very hard to set all of that data up to the cloud without it being expensive, or maybe it didn't actually make sense for that scenario where time was really important. So for this one, worker health and safety for construction and manufacturing, one of the challenges is difficult to enforce worker safety protocols. And so a solution for that is people detection and tracking combined with object detection to identify unsafe conditions, to be able to better enforce the safety protocols. And I really want to just skip to a video here. I worked with Marston Group and NVIDIA and Seadrill on this particular project. So I wanted to showcase it because I thought it was a really great example. It was actually one of the first partners we worked with when it came to really deep diving into what does it mean to bring AI to the edge, and especially in the workplace safety scenario. And so let me just showcase, see if I can show this video. So as I mentioned, Marston Group is one of our partners, and we worked with them on this drilling scenario, and it was a workplace safety, but it was on an oil rig. Here we go. Glad the video is playing. And so the drilling industry is really has a lot of challenges, especially where not everything's connected, and a lot of things need offline capability. And one of the biggest things is really managing red zone areas on the drill floor. It's really hard. So imagine all of this equipment is moving around. Some of the equipment is, slightly automated, and then you have workers doing manual duties. So we worked with Marston, Seadrill, NVIDIA to team up to make Vision IQ. This is made by Marston as their property solution, but Vision IQ is a combination of vision processing, LiDAR, edge computing, but it offers identifying, tracking, and predicting movements of people and equipment. So you can see here, you can see the equipment is moving. We're able to actually locate a person. And this is really important because we could detect, inform, and act. So if, let's say, this moved over and got close to a person, we can stop this piece of machinery before it gets to this person. And there's so many close calls when it comes to oil rigs or potential for close calls. We really want to make sure that we can alert these workers or stop a piece of machinery from something bad happening. And so you can see there was an alert saying danger, danger, and the piece of machinery, went off to the side to make sure it wasn't going to hit that particular person. And how they're doing this is that they have these different types of a different type of setup, camera setup with LiDAR, and it's across the different places on the oil rig, where they're actually able to identify these folks, do tracking, and do this predicting of movements and people and equipment. And so this really, you can see they're identifying that those are people, that these are different equipment, where the equipment is. Here's an example of what they built. But all of this is being deployed on the edge, because you can imagine when you're on an oil rig, the Wi-Fi is, you're in the middle of nowhere. And so Wi-Fi is extremely difficult. And then also, if a piece of machinery is going to hit someone, you need zero latency. You need to be able to do real-time actions and also be able to do processing and understanding of those insights to be able to do the right actions. So I really like that case, and I loved working with the partner as well. So wanted to showcase that. We also have the several pre-built AI containers from Cognitive Services, so custom vision, face detection or facial recognition, and text recognition. Keep in mind that if you are building these solutions that deploy AI on the edge, there's a couple different ways that you can think of it. You can actually use these already pre-built AI containers, that can help you accelerate your time to market, or you can create your own AI containers, and that's great for companies who already have a team of machine learning experts who can create those models, and then then there's a combination of using open source options out there as well, and combining it and making some changes for your particular solution. So there's a couple different things, ways you could think about bringing AI to your device. And they all have their pros and cons to them as well, depending on your particular company. So we do have support for NVIDIA DeepStream. If you haven't checked it out, I really recommend it. Also, NVIDIA has an amazing Jetson line. It's great for AI on the edge workloads. So anywhere from autonomous vehicles, or maybe you just need to do some facial recognition. Really check out what NVIDIA has. I'm not sponsored by them. I wish I was, but we definitely have used them a lot with different partners and customers, and being able to have a set of hardware that you can easily be able to deploy models to makes things easier. And have a couple links to that at the end. I know I'm kind of glossing over that one real quick, but I did want you to know that if you are familiar with NVIDIA DeepStream, that it does have IoT Edge support for it. And then managing your data. So there's a couple different ways to think of this. If you have telemetry, you can store and forward upstream via the IoT Edge runtime, or you can store and query it locally from different databases. So we do have support for, SQLite, SQL Server, Redis, and then for large files, you could do that local blob storage, and that's great for images, videos, and you can also use you can use blob storage as auto tiering and auto purging capabilities as well. The store includes store and forward for intermittent connections. All right, so let's talk about tooling support for IoT Edge. So we offer a lot of different tooling support here, especially for Visual Studio. We've had tooling support for a long time for Visual Studio for IoT Edge. And then Visual Studio Code, we actually have an extension. The extension is really nice. Let me just pull that up real quick. So if you just go search for extensions, you can easily just type in IoT tools, and this is actually an extension pack, and this extension pack will get you the IoT Hub support. This is really nice, especially if you want to just easily create an IoT Hub, do device to cloud messaging or cloud to device messaging. This extension is really nice to be able to set all of that up. And then you have IoT Edge support, where you can create an IoT Edge solution, create modules. So this is really great as well. And then this device workbench, really that is all of our devices and the certification. Think of it as a nice way to be able to work with those devices. If you have the MX chip or the ESP32 or Raspberry Pi, we also have support for them as well. And so this is just a nice way to easily work with those different devices. So, or you can just download the IoT Edge extension itself if you would prefer to go that route as well, instead of the extension pack. For DevOps side, we do have IoT Edge support for Jenkins. This one's a really big one because there's a lot of folks using Jenkins, and to be able to have that support helps unlock more folks to be able to use IoT Edge. And then we also have IoT Edge Task for Azure pipelines. We have Azure DevOps projects for IoT Edge as well. And then if you want to do everything through the command line, you can create an IoT Edge device in the command line. Keep in mind, if you're using the Azure CLI, we do have an Azure IoT CLI extension. So you are going to want to install that extension if you're doing everything through the command line, because if you try to run some commands, it's just not going to work. And most likely is because you haven't installed this extension. This just kind of gives you a little bit more look on, you can develop those custom modules with VS Code. And you can see that we have a lot of different abilities that you can do using that extension in VS Code. And then DevOps, so Azure DevOps, we have really great tutorials on how to work with Azure DevOps, and I'll give some links at the end as well. Perfect. Let's go ahead and jump into setting up and deploying an IoT Edge device. So one thing there's a lot of different ways you can do this, and I'm just going to kind of show what we're going to be doing. So we're going to create the Azure services and solutions to be deployed on the edge. And then we're going to create the containers, store. The next step, you're going to store them in a container registry like Azure Container Registry. This is the kind of the normal steps. You're going to create that deployment manifest in Azure IoT Hub, and then create a deployment manifest. Then you're going to deploy that onto your edge device. So today for the lab, what we're going to do is actually have a temperature sensor. And then I'm going to showcase using Azure Stream Analytics support as well. And so this is, we're gonna do this for the lab today. All right, so I have a dummy account here, and one of the first things you're going to want to do is actually create an IoT hub. You can create an IoT hub a couple different ways. You could do that through VS Code. You can do that through the portal. You could do it through the command line. So if you're going to do it through the portal, you can create a resource. Just click on Internet of Things, and you can click on IoT Hub. And I already have an IoT Hub already set up that we'll go into, but I just want to showcase this real quick. So for this IoT Hub, you're going to select your subscription. If you don't have a subscription, we do have, a free tier of IoT Hub, and if you sign up for Azure subscription, it's definitely a great deal because there's a lot of, especially for the first 12 months, a lot of free services as well. So you can create a resource group, or you can select a resource group you already have. You select your region and enter a name for your IoT Hub. Next, you're going to actually select the size and scale. So for IoT Hub, you have different tiers, different SKUs. You have the basic one, you have free, and you have standard. And if you're ever wondering what those tiers mean or those SKUs, I always recommend just going to the Azure IoT Hub pricing page, and it breaks down what's supported. So you can see for basic, IoT Edge is not supported, and that makes a lot of sense because basic, all that is, and this is great for particular scenarios, but the main thing for basic is that it has device to cloud telemetry, and it's for those particular scenarios that doesn't need the cloud to device telemetry back. And so the standard actually covers cloud to device messaging, device management, device twin, module twin, and IoT Edge. And you'll notice that you actually have that free option as well. IoT Edge is supported for free, and the difference between standard and free, you can see that right here. It's just really the number of messaging and also message meter size as well. But for IoT Edge, you can use anything on the standard or free, and it works out great. I just have it for standard. I could have it for free. I'm just running a lot of demos, so my messages, there's a lot of messages I am sending up. All right, so let's say we just created that IoT Hub, which I already have, and IoT Hub doesn't take a very long to create, but I want to make sure we have enough time to go through everything. So this is what your IoT Hub looks like after you create it. And lots of times when people get started with IoT Hub, they go to IoT devices and create a device. Well, actually for IoT Edge, you do have a section under automatic device management for IoT Edge. And this is where you're going to add an Edge device. So I already have an Edge device already running, but if you want to create an IoT Edge device, let's go ahead and create a third Edge device. You could choose a couple different, the symmetric key or the X509 option for authentication. You can also do this with, if you're using device provisioning service, there is X509 support for DPS and Edge. That's actually fairly new. And then for today, we're just going to choose just kind of a basic SaaS offering or SaaS tokens. So we're just going to have it generate keys and go ahead and hit save. And so it popped up, and if for some reason you don't see it pop up right here, there is a refresh button. So I always like to remind people of that. But let's go in here. So we just created this device, and you can see that we have those two system modules. So we have the Edge agent and the Edge hub, which we talked about earlier. And you can see that they're not running at this moment. If we go to, well, go back to other Edge device, and the first one that I already have set up, I actually have a simulated temperature sensor module set up. I have an IoT Edge job already deployed. Really what that is Azure Stream Analytics. And we'll talk about that in just a moment. So I'm going to go back to the Edge device that we just created. So part of this is that when you're working with this Edge device, you're going to want to know what that connection string is. And this is where you find that connection string information. So I'm just going to copy. And there's a couple of different ways that you can get started with IoT Edge. One, you can install the IoT Edge runtime on, let's say, your local machine or your edge device, or you can also, create a VM to get started with. And I always recommend, if people are just getting started, go ahead and deploy on a VM and run through the experience before deploying on an actual device. Or your edge device. But we have, under Run IoT Edge on Ubuntu virtual machine, we have a nice page here where it's deploy using the Azure button. So this is just using our ARM template. So if you're familiar with ARM templates, they're Azure Resource Manager templates. So we did this nice setup for you. So if you want to use a Linux VM, this is the way we would recommend it. Or you can do everything through the command line as well. Remember to install that extension. So for this one, let's go ahead and deploy it to Azure. For those who probably know, in the marketplace, we do have an IoT Edge for Ubuntu already on the marketplace. I recommend going here. This is kind of our new guidance on if you are running IoT Edge on Ubuntu virtual machine, to use this instead of using the one on the marketplace. And that's just based off of feedback that we've heard from partners and customers, is that they would prefer an ARM template for them to use. So when you're doing a custom deployment using that ARM template, you can go ahead and create a new resource, or you can use your particular resource if you want. I'm going to just go ahead and say resource edge 3 region. You can select a region that's closest to you. You can go ahead and put your DNS label prefix. So if you want to go ahead and do that, you can actually choose anything that you want, or the required, or you can put what you want here. But this is pretty much, it's used to be the prefix of your host name of your virtual machine. So I think I'm going to just do workshop. Edge. Okay, and then admin user. So I'm just going to do user 01. Now, remember that I mentioned that you need a connection string. So what's nice about this ARM template is that it's already set up where you can just go ahead and get your connection string of your IoT Edge device and go ahead and insert it in. And then you're going to go ahead and choose a password. So this just can be any password that you want to use. So I think I'm going to try to use something other than password, of course. We'll definitely want to be secure. Now you're going to go ahead, make sure you have everything selected, your VM size, the version that you want to use. All of this was nicely made by that ARM template. We're going to run a validation, and validation is passed. Go ahead and create it. And we're submitting, and deployment is in process. So VMs take a little bit longer, so let's go ahead and go through why that deploys. I'll walk through the other example. So in order to go ahead and create modules, you can do it a couple different ways. You can go to Set Modules. And how I added the simulated temperature sensor is that I actually went to Marketplace module and did temperature and we have a standard simulated temperature sensor that you can use. So that is a module already ready. It simulates temperature, humidity. So that's something you can go ahead and deploy or use. And then for this, I actually added the Azure Stream Analytics module. A couple of things to note when you're using the Azure Stream Analytics module. There are some steps that you want to do before you actually are going to want to set up your actual Azure Stream Analytics. And a couple steps to do that is first you're going to create that storage account, and that's really important, especially if you're using Azure Stream Analytics. And so when you create that Azure Stream Analytics job to run on the Edge device, it needs to be stored in a way that it can be called from the device, and that's why you create an Azure storage account, which I've already created. You're also going to create a new job. So if you're familiar with Azure Stream Analytics, you create a job. You can do that in the portal. So I've actually, let me go to my Azure Stream Analytics job. So I've created one here. You can go ahead and add if you wanted to, but I've already created one. And what I did is when I created the Azure Stream Analytics job, I did input, and that input is actually I input the Edge Hub. And you can see I already have one for temperature, and I put stream here. And then for outputs, I added another Edge Hub for my output, and that output I called alert. So in the query for Azure Stream Analytics, just added some information to the actual query itself. And so this one, you can use this code, but this code is pretty standard one, but all it does is it's a command where if the temperature of that simulated data reaches 70 degrees, what's going to happen is it's going to end up resetting the actual IoT Edge. So I'll give you an example and show it to you in real time. So after you've created your IoT, your Azure Stream Analytics job, you can go back to your IoT Hub. So I'm going to go pretty quickly on this. Here, you're going to want to make sure that all of these are routed to talk to each other. So you can see here, I have a telemetry to cloud. It's the simulated data from the simulated sensor is already going to the cloud. Alerts to cloud, my Azure Stream Analytics goes upstream, and then alerts to reset. My IoT Edge job, which is my Azure Stream Analytics module, resets when it hits to 70, above 70 degrees, and resets that actual module, and then telemetry to Azure Stream Analytics. So you can see these different routes, how they route to each other through talking to the module and then sending upstream to IoT Hub. So I've already created. So when I go to my terminal, I'm going to go ahead And I'm just going to see this in action. So I've actually, my Edge device has been sending up temperature, pressure up to IoT Hub. And so that's good to go. And once it reached to above 70, it actually restarted IoT or restarted everything. So you can see resetting, it's just resetting the temperature sensor because the temperature averaged in that it was greater than 70. So it ended up resetting. So I recommend checking this lab out in order to see how everything works with Edge. But you can see that you have your different modules. You can add your modules here. You can route between your different modules, and then you deploy. So you can see this is your manifest that ends up deploying on your actual device. So how to get started is that we have a couple different pages here. So you can start with Azure IoT Edge vanity link. This will take you to our documentation, or this will take you to our landing page of IoT Edge. We also have the getting started guides and docs. We have a couple different workshops. I'll go through these pretty quickly, but all of these links, and if you want access to this deck, we will be reach out to us and we can send that out to you. We'll also, after all of these virtual workshops are done, we'll be sending these links out on Tech Community. And then to go through a lab of what I just went through, how to set up, deploy Edge device and develop those modules, you can go on MS Learn, and Microsoft Learn is a sandbox environment. You don't need an Azure subscription to get started, and we have one just for Intelligent Edge, which is a great one to get started with. And so you can go to aka.ms, MS, IoT, I think it's, let me pull it up. MS Learn IoT, or you can go to any of these learning paths as well to get you to MS Learn. And then we have other resources like Tech Community, our learning paths. Here's that vanity link for you to get access to the IoT Edge. And then we have a developer guide where you can learn how to build IoT solutions, what are the best practices. And then IoT shows. So I made a mention before, we have tons of really great materials on this. So we have on our deep dive series, one, building IoT solutions with IoT Central. This is about building with IoT Edge. We really deep dive into that. And then if you are someone who specializes in DevOps and you want to understand how to use CI/CD with IoT Edge to deploy IoT Edge modules, we have a full episode on that, and then machine learning on the edge with predictive maintenance, and then a lot more episodes as well. And then you can join myself and others if you have questions on the tech community. It's aka.ms, IoT Tech Community. And you can check out the NVIDIA IoT Edge device line as well if you are super interested in playing around with IoT Edge devices that have AI model or machine learning on the edge solutions. So sorry I went over, but hopefully you guys can get started, and if you have any questions, let us know. Definitely join me on the IoT Tech Community. We'll be able to answer questions there, and thank you for joining.